In this video, we will be discussing laser line probe best practice tips and tricks. Best practices when scanning. As much as possible, use a consistent angle and a consistent distance when scanning any surface. For a non-reflective or matte surface, the angle of the laser line matters less, but best practice is that it should be perpendicular to the part's surface. To ensure this, hold the laser line probe with the hard probe pointing directly at the surface of interest with the camera at an angle. For reflective surfaces, the angle of the laser beam is more critical, and the laser line should be angled to the part's surface. Achieve the optimal angle by orienting the camera so that it is parallel to the part of the surface. This ensures that noise-induced reflection from the laser are projected away from the camera. Hold the grip handle steady while you're removing the LLP over part surfaces. Avoid rotating it. Best accuracy can be maintained by using a consistent angle and consistent distance when scanning any surface. That and regular pauses help maintain the movement of encoders during a scan. When scanning with an 8th axis, do not rotate the 8th axis as you acquire scans. If you need to rotate the 8th axis, be sure to pause your scan before rotating. Do not overreach when scanning. Position your body, arms, and hands such that the section of the part you are scanning fits comfortably within your reach and body stance. Use 2 hands on the pistol grip if necessary. For smaller objects and higher density, scan the part in the near field of the LLP's range. For larger objects, scan the part at the far field of the LLP's range. When scanning sharp intersections for inspection, scan each surface separately with the camera angled so the LLP cannot capture data on multiple surfaces at the same time. For reverse engineering, additional scans for an appropriate angle to capture data on multiple surfaces at the same time, an appropriate angle of incidence can be beneficial. Note, the camera is pointing away from the side of the surface that the camera is moving towards. Note, it captures the top surface, but when the laser starts to run down the side surface, the camera does not see it. Therefore, it does not collect any data. Start and pause the scans with each pass so that data is processed in bite-sized chunks as you go, instead of one lump at the end. Regularly stop the scan to enable data to be transferred to the hard drive. This frees up RAMs and helps prevent the computer from being overwhelmed by the size of the point cloud. To continue, just add to that scan. Note, in Cam 2, the red data is data captured at a high angle of incidence and should be captured again. Scan feature lines with a laser line perpendicular to the feature. This enables the highest density to be applied to the most rapidly changing detail. Angling the laser line to around 45 degrees on the boundaries of parts allows the edges to be captured at a resolution higher than the normal and without the need for multiple overlapping scans where boundary change direction sharply. Divide your scanning project into logical parts that enable you to observe best practices as you go, by reducing data capture to manageable portions without compromising results, without inducing unnecessary fatigue, and whilst keeping track of your progress so you capture all the data that you need. Avoid putting the arm back into rest position once you've started and until the scan is complete. Note, when taking a pause between measurements, it's okay to rest the arm so the elbow is still floating. Avoid putting the arm at rest position until you have completed capturing all your data.